I just wanted to talk about acids, bases and salts at GCSE level, but before I do that I just want to say one thing, is that I am really finding that doing these GCSE chemistry videos is really limited. I feel like the GCSE syllabus is really dumbed down, you have to tell half-truths all the time, and it is also made particularly boring. And another issue is that it's very much biased towards the inorganic chemistry side of things. Anyway, I will plough on with it. First of all, there is a definition of acids and a definition of bases, which are, if soluble in water, are alkalis, and I shall talk about that. Now, an acid is supposedly something which, when it's dissolved in water, produces hydrogen ions. And a base, or rather an alkali, is something that, when it's dissolved in water, produces hydroxyl ions. Now, obviously something can produce both. When it produces both, it's known as amphoteric. Now, examples of bases are harder to find than examples of acids on the whole, but an example of a base is sodium hydrogen carbonate, otherwise known as bicarbonate of soda. I don't know why it's called bicarbonate, because it's not bicarbonate, it's hydrogen carbonate. But anyway, there you go. Another one is caustic soda, which is the stuff that you use to unblock drains. You can also make soap with it, as you will see with other videos on this channel. An example of an acid is, and here I've chosen an organic acid because they are so much easier to find, vinegar. Vinegar is ethanoic or acetic acid. The organic acids have carboxyl groups on them, and what happens is that the hydrogen becomes dissociated with the molecule, and you end up with hydrogen floating around in the water, supposedly, which is not what happens at all. And another one, obviously, is citric acid. And the reason I always choose limes is that limes are the most acidic fruit that contains citric acid out of all of them. And obviously they're called citric because it's named after citrus, which is the Latin generic name for all of that kind of fruit: oranges, lemons, grapefruit, etc. Acids and bases are measured on a scale known as pH. If something is acid, it has a pH below 7, and if something is alkaline or basic, I should tell you the difference between those two, then the pH is above 7. What it is a logarithmic scale. The 7 and it indicates how many hydrogen ions, supposedly, and hydroxyl ions are in a solution of water containing that acid or that alkali. A base which dissolves in water is known as an alkali. I think I've already said that, haven't I? The reason it's logarithmic is that each step on the scale produces 10 times more or fewer, depending on which direction you're going in, hydrogen, supposedly, or hydroxyl ions, according to the step along. Hydrogen ions, in other words, acidity is at the bottom, alkali is at the top, neutral is in the middle. Alkali is at the top, acids are at the bottom, neutral is in the middle. If something has a pH of more than 7, it's an alkali in water. If it has a pH of less than 7, it's an acid in water. If it's in the middle, it's neutral. Acids are at the bottom. I think it's important to repeat this. Acids are at the bottom, alkali at the top. Okay, so I'm just going to squeeze this, and then I'm going to talk about how to make a pH indicator easily at home. So you got your lime and you squeeze it like this. Now, one thing that's important to bear in mind is that in GCSE chemistry and in organic chemistry in general, in fact, the acids that you use are actually inorganic acids, which are actually a lot stronger. As a result, they're quite dangerous. Now, I'm also going to show you a test for carbonates here. Okay, so I've got my lemon juice there, or lime juice rather there, and I've got my bicarb here. Sodium hydrogen carbonate, citric acid. Pour that in there, and you'll see that it fizzes quite dramatically. What's happening there is it's releasing carbon dioxide. Now, that's what happens when you combine a carbonate with an acid. Now, the result of that is that now contains a salt known as sodium citrate. Because a salt, it's not this stuff, a salt is combined acid and alkali, acid and base. Another thing you can do is make an indicator, and I'm going to do that now. There's going to be a gap while I do it. I'm just going to start off by getting my little 20p red cabbage, which was good value for money actually, considering, and chopping it up. Now, I've got an entry on my blog about anthocyanins, which you can look at if you like. The reason that cabbage works as an indicator, red cabbage works as an indicator, is that it contains anthocyanins which change colour according to the pH of the solution that they're in. And in fact, many plant colours, many colours of flowers, arise from the fact that the anthocyanins are in there, but it depends on the environment that they're in, and it can be an acidic or alkaline environment. And so a lot of colours in actually flower petals and so forth are actually based on anthocyanins, even though there are loads of different colours. Now, there's going to be a part 2 in a minute, but for the time being, I'm going to put this in here, boil it for a while, and then I'll show you the result and then compare it. So, see you in a couple of minutes.